All right. So today we're kind of launching into your projects. So the first thing I wanted to do is bring in Megan. Megan is a biomedical engineer, and she's been at Stout 4 years, just over 4 years, I guess. And her focus is in rehabilitation engineering. So she works with the Stout Vocational Rehabilitation Institute. The theme that we're going to put around our projects is assistive technology. So assistive technology, I guess, very broadly defined, would be technology that assists humans to do things. And oftentimes it's focused towards persons with disabilities and kind of tackling various challenges that they face. So Megan's going to give us a little presentation to talk about some of the issues around assistive technology and kind of intro that area for us so that we can have a little bit better understanding what that means, and then hopefully give you some things that you can research to kind of take it forward further and as we start to specify our projects. So with that, I'll let Megan give her presentation.
How are you guys doing today? So as Devin said, yeah, my degrees are biomedical engineering, and I practice the specialty of rehabilitation engineering. And it's one of the fun ones. I mean, there's lots of different sects of engineering in general you can go into. But the reason why I chose it is it's very, very hands-on. It's very interactive. I'm working with the people with the disabilities and not sitting behind a computer all day. And that's kind of what pulled me into it. In my undergrad, I did a research experience, realized that research is not my personality. It is now, but it wasn't then. And that hands-on engineering aspect, which is what we all love when you're in school and everything, that was a really big pull to me. So when I work with people with disabilities, I'm actually providing assistive technology assessments, and I am figuring out how to integrate your person with a disability to their environment and to reach their goals. And we use assistive technology because that is the tools and strategies that we use to improve your level of function and reach your goals. So when I work with somebody, I go out, I meet with them, I figure out what they're struggling with, and a big part of it is just helping them interface better with their environment or whatever they're trying to do with their task. I buy as much of that as I can off the market shelves. There's a lot of products that are already out there. But then when we can't buy it, we modify it. We'll take something that we can. It might not have a big enough handle for somebody that doesn't have a grip, and so I'll do a custom handle or grip that they could use. If I can't modify it, then we fabricate it from the ground up. And so we do all those aspects. Engineers are not required to do, it is not required to have an engineer to go out and do an assistive technology assessment. There's a lot of people that don't have engineering backgrounds that do that. But as you get more into the modification and fabrication, that's where the engineers come in. And there's 2 of us that are engineers over at SVRI, which is over on campus. If you guys ever want a tour, just tell Devin, he'll give you my name, we can help you out with that. So as you guys are very well, all you guys are engineering majors, right? About? Not quite? Okay. So you know the engineering design process, and that you're identifying the need or the problem, researching the need and the problem, then you come up with your possible solutions, you choose your best possible solution, you make a prototype, you test and evaluate it, and then you communicate it out. And I like it because it is a process and it's iterative, but another diagram that really shows it is that your iterations don't have to be the full loop. You can keep going back steps until you're ready to move on to the next one. So I use both of them. Well, when we're talking about the design process, when you're working with a person with a disability, it's not very much different than what you guys have already learned or are learning. But one thing that's really important is identifying the need or the problem. And so that's what I'm going to spend a little bit of time talking to you guys today about, is really all those extra thoughts that go in to determining what you're trying to solve so that you come up with a good solution. And an example, I was at a presentation over the summer that was talking about this and how they teach their engineering students how to do fabrication and senior design classes. They're a lot of the times based on assistive technology needs at some of the schools. And they had a problem of you need to design something to mobilize a 2-year-old out into the community. And so they came up with this little motorized wheelchair, essentially, that a 2-year-old could drive. Well, they didn't know the problem all the way. What the real problem was figuring out a way that the family could mobilize the 2-year-old out into the community, which would be something more along the lines of like a stroller or a wagon or something like that. So really understanding that problem before you spend your whole semester working on the wrong problem is really important. And I mean, we all do it, and you always go, oh, I was in left field. But the more you incorporate these tools into it, the less often you waste your time in left field, and you only tangent there, kind of thing. So identifying the problem includes defining it, and you need to figure out who your customers are, who your stakeholders are, and what all the resources you have available, and the constraints. When you're doing that, who are you talking to? I shouldn't have given you guys all the answers. So the person with the disability, that generally is our end user. Really important and very closely integrated into that is our support team. There are people who are helping take care of the person with the disability. So if your device requires some process of setting it up and taking it down or moving it, or if they can only move their head and they're going to need help with troubleshooting it, it has to be something that the caregivers are capable of doing at their technical level of expertise, at their physical level of capabilities, and with all the other parts of their job that are part of it. So you want to really include all that. And then the other professionals, maybe you got therapists and stuff like that. So a little bit more in depth. You're talking to your person, and this is really as you're researching the problem, keep going back to that person. You don't have to only talk to them once. Keep going back. And don't forget that just because they have a disability, that doesn't mean that there's nothing going on there in their brain, especially if you're working with somebody who can't communicate very well. One thing that I get back as feedback when I work with people that are your age who have autism is it's the biggest deal to them that I talk to them like a real person, and that I'm asking them what their opinion is of what they like and not what their parents feel that they should have. And you want to treat them like an individual. Never ever talk about them, always talk to them. And even if their family is helping answer, you're talking to the person and the family is filling in. And that's a really good etiquette. And really you want to do that anytime. You wouldn't feel good if somebody was talking about you in the room just because you had a sore throat and you couldn't talk at all. You don't want someone else talking for you. You still want them to talk to you even if you're not answering. So with our projects, I have a couple suggestions that we're going to talk about at the end, but your support team isn't just the family or the caregivers. The friends or the peers can be part of that. How are they interacting with the person? What about teachers if you're working with kids or somebody in the school system? The babysitters. Kids interact differently with babysitters than they do with their parents, kind of thing. Neighbors, what are they observing going on? What do they recognize? And that's always, you don't want too many people, but you want enough people. So talk to everybody, figure out who's really providing valuable information, but file it away. You can filter all that on your own. And then OT, PT, and SLP, that's an occupational therapist. That is the therapist that helps a person work on doing their life tasks, their activities of daily living. So it's kind of, in the work world, it's helping you work. But it's also eating, brushing your teeth, combing your hair, showering. All that kind of stuff falls under the realm of the occupational therapist and what you need to do to accomplish everything that you need to do in your day. A physical therapist is a little bit more focused on function and strength, and so there still is a little bit of getting you through the day, but it's more the mobility aspect of it. It is having the strength so that you can climb stairs on your own, and the coordination to do that, the coordination to walk independently. Those are some of the bigger physical therapist type goals. And a speech and language pathologist covers a huge array. Sometimes it's how you swallow and eat. Sometimes it is how you're verbally communicating. but it's also the cognitive processing that's involved or required to communicate. So if you have autism, sometimes the problem is not with the mouth and the oral motor control to make the words come out. The problem is a breakdown between the brain and getting the words out of the mouth. And so that's where the speech and language pathologist, it's not just voice, it's a lot of the processing and everything else involved with the communication aspect. So all of them have a huge impact and a huge perspective to the person that you're working with. If you can't talk to them directly, reading some information about it. Now, this is all really important when you're designing something for one specific person. You still want to talk to all these people, but lots of these people in a lot of different environments if you're designing something that's going to be used for lots of people, okay? We also want to include some other people. What about your manufacturer? So you want to think about the manufacturability of your device if it's not going to be a one-off. What about the people that are making similar products? And we'll talk more about that in depth in a little bit. So I don't want you to forget about the user. And so I'm going to hammer this in because we don't want to forget about them. They're your best resource. But just because they can tell you what the problem is, does not mean that they know what's out there at all for the technology capabilities of a solution, or a lot of them don't even know how to look for a solution or the words to use. So I work with a lot of people and they go, I just wish there was something that would remind me to leave before my appointments and enough time to drive there. Well, there's an app that does that. I just need something that reminds me to take my medicine every hour. But they might not be aware of what's out there. So sometimes it's finding what's aware, sometimes it is actually looking at. So, and then you get the people that go, well, I want this machine that's going to make me fly and make no noise, and I can do everything from it, and it's going to move, and you're going, and I want to control it all with my brain. That doesn't exist yet. We don't have great brain computer control that's fast and efficient, where as soon as you think the thought, it lifts your hand up and goes and does that. But you get people that request it. So they don't know what's out there. They just know what the problem is. And you want to keep them involved throughout the process. Don't go to them with, I meet with you, what's the problem, okay? And here's the prototype that took me 6 months to make. Will you try it out? And they're like, oh, you totally missed the boat. The problem is not what you thought it was. You're solving something that I have a reacher that can do, okay? So you want to, as you're thinking about it, as you come up with a couple concept sketches and you're showing them pictures of things that are out there on the market and going, well, why don't you like this? Or maybe they've just never tried it and it meets their needs. And so you want to keep going back to them and involving them throughout your whole thing. And in the bigger scheme, when you're not working with somebody who has a disability, you still want to do that. And you want to always keep going back to your customer with whatever it is that you're working on. I mean, don't waste their time, but make sure they're very involved. Okay. The user also can be more than one person. And that's that aspect where I was giving you the example. So if I want to help my person with a disability use the computer, they are the number one user. They're interacting with the computer. But if their workstation is shared by a lot of people, then all the people sharing that workstation and sharing the computer are also my users, because whatever my solution is can't get in their way either. And if he can't set it up on himself, by himself, then the caregiver or the family member who's setting it up for him is also my user. So we have a lot of users that are coming at from different angles, okay? And then there's resources that can help us supplement our users, and this is as we're gathering information and trying to really understand our problem. We want to use our other resources that know a lot about users, and if you're doing something for lots of people and not just one person, they know the caveats that aren't unique to that one individual that you might have missed, like spinal cord injuries. A C4 spinal cord injury presents similarly across people. That some people can shrug their shoulders. If they have incomplete spinal cord injury, they might even be able to lift their hand and place it outside, but they might not be able to get their hand back inside. And if you only know one person with a C4 spinal cord injury, you might know that all they can do is shrug their shoulder, or that person can move their arms, and you're not realizing that the vast majority of them can't, kind of thing. And that's where your clinicians, your caregivers, healthcare professionals, experts that really work with the different populations can give you the broader spectrum of the other things that you've got to think about, so you can get to that least common denominator when you're trying to design something for a larger population. So do you fully understand that problem? Do you have clear goals and objectives? Did you include that user perspective? Did you look at standards of care and the best practices? So an example of this when it comes back to disabilities is that we have to do pressure relief. You guys are all sitting in your chairs right now and you're fidgeting, you're wiggling. Nothing wrong with that, that's what we all do. And it's what you do when you kind of start losing blood flow to an area, and it's before you even feel it. You've already shifted your position. If you have paralysis, you can't feel that your butt's getting sore. And therefore, you don't wiggle, plus you don't have the mobility to wiggle. So you have to do something called pressure relief. Well, if we go out there and pressure map a bunch of our consumers, and they say, I do my pressure relief every 2 or 3 hours, and I have a power tilt function in my wheelchair, and I go back 30 degrees. It's not providing pressure relief. That is what they're doing, but the standard of care is to tilt all the way back at your maximum level of tilt in the wheelchair, which you can't drive from, and you need to do that for 2 minutes every 90 minutes. That's the standard of care that we really want to be addressing and accommodating, and keeping that as part of our perspective in our design, kind of thing. Not what they're doing that's a little bit subpar. Because if they got a pressure sore, or somebody educated them better with pressure mapping and that kind of thing, they're going to shift, hopefully, to our standards of care. There's also equipment standards. So when you gather more information, the internet's a great resource. Don't forget about the library. I know it's that archaic building over there, but they've got a lot of great resources. You don't want to forget to use them. Patent searches. Now, this is something that you guys probably are aware of. Patents, the Google patent search function is really, really awesome and robust. It didn't exist when I started college, so I'm always really excited to share it because it wasn't a tool then. And catalogs. Shopping through catalogs. And Google image searches is another way of doing catalogs. So you just come up with different ways of describing what you're trying to do. And you look at all the pictures, and somebody might have an option. So one of my suggestions for you guys for projects is related to play. So I threw in 2 websites that are for product catalogs for toys for kids with disabilities. Most of the toys, like playing is something that's really, really hard, especially if you have a physical disability. You're up in your wheelchair. You can't get down onto the floor very easily. You might need somebody to take you out of the wheelchair and reposition you on the floor. You don't have good postural support, so you can't support yourself when you even are sitting. So maybe you've got a beanbag kind of pushed all around you to hold you. Well, now you have all this stuff around you, and the kids over there are wrestling, and you can't wrestle with the kids. So how do you get to play with them? Well, one thing is we have action figures, or all those battery-operated toys. And what they do is they open them up and they create a battery interrupter, and then we use a switch closure, and when you hold the switch down, it causes the toy to go. And so you might be able to have Buzz Lightyear make a saying every time you do it, or you get the train to go forward. Another example, this one is a wireless system, but there's 3 switches that are bigger and more modified, so that if you only have gross motor movement, which means that you don't move your fingers in fine resolution, you can more move your hand or your arm, but you can't get to the small things. And so those 3 big buttons allow this person to use a remote control car, and they can race with their siblings. These tools also have therapeutic goals. So if you're an occupational therapist or speech and language pathologist, and you're trying to teach somebody about cause and effect, or yes and no, this is pretty young kids, or it's a little bit older of a kid and you're trying to get their arms a little bit stronger, play them with that little exercise ball, or just pushing, tapping or pointing at a green and a red circle on a piece of paper. Those are really boring. That's not a motivating task to do your therapy. So we use these toys also for therapy. But a big part of it, a lot of kids just want to play like the other kids. As you're researching your solutions, don't forget to see what kind of research is out there. Looking at newspaper articles, that's often how I find out about new products. Is somebody in a disability magazine has written it, or it's on CNN. Often I know about them ahead of time because I was on a listserv, and my listserv said, hey, I just found this cool new product. And so those are other ways to get some more research going. And looking at all the products that are out there on the market. What's already addressing that problem? What is not designed to address that problem, but it's being used off-label in a way that meets that need? Or is it getting the whole problem, or is it just doing a small aspect of the problem? So, for example, feeding. There is a device out there that will hold a sandwich for you. So it holds it right up here in a clip, so a caregiver goes and puts the sandwich in there, and then you can only move your head, but you can eat your sandwich. That is addressing the problem of eating. Is it addressing the whole problem? No way. What's it missing?
Being able to adjust your sandwich.
Pardon?
Being able to adjust the sandwich or anything.
Adjusting the sandwich, that's one limitation of it. What else? When we think of the big goal of eating, is it addressing all of eating?
Anything that's not a sandwich.
You can't eat anything that's not a sandwich. And what about one more aspect of eating?
Somebody still has to help them.
Somebody still has to help you. You're not fully independent with it. So you're looking at, okay, this is out there, but these are the limitations of the product. And that really helps you come up with some of your constraint lists too, and your design specifications. And then there are equipment standards. So if you're doing anything related to transportation for somebody in a wheelchair, there's standards out there that have been adopted and passed that you will want to comply with. So why aren't those products working? And you can look at it, and I don't want you to ever forget about aesthetics. I have a lab full of assistive technology that I never even bring to a consumer's house because it looks so geeky that 98% of my consumers would never try that keyboard. It looks like something from 1975, and it's huge, and it's got weird curves, and I don't look like a regular person using that keyboard. So we don't bring them because it is not aesthetic. Sometimes I do when I have extra room just to show them, but I've been doing this job for 8 years now. My boss has been doing it for 25 years. I think he's recommended that goofy, awful, ugly looking keyboard once. I've never recommended it. So aesthetics are really, really important. People with disabilities don't want to stand out. And that's why the iPad is so popular. It's a great piece of assistive technology. And it looks like everybody else's. Disadvantage, something to think about. The iPad's not the solution for everything. But that's another battle that we have to overcome. Okay, so once you have your feel on the problem, you need to go and communicate how you're interpreting the problem so that you can make sure the others that told you the problem in particular, but that everybody's on the same page. And there's one more big advantage of that, and that is 2 or 3 months down the road when you get into your tunnel, you can always take a step back and look at your big picture again, because you don't want to ever forget your big picture. And you can remember what you were thinking and why you chose that design criteria. And that's because if you decide that I just can't meet it, well then you can remember how important it really was. And so what I recommend doing is coming up with a problem statement. And my problem statements are kind of long and detailed. I put in everything so that I can remember it later. There's the background on the population of people I'm working with, and explanation of the disability, so I don't have to conduct that research again if I've forgotten it. What is the problem? Not what is my solution, not what are my ideas, what is the problem? And what is the goal and the scope that I'm trying to do to address the problem? The problem could be world hunger, but you're addressing a small component of it sometimes. So that's why those are two separate things. Talk about all the ways that the problem's being addressed and their strengths and limitations. Also, all of your design criteria. What are the needs? What are the wants? What is the priority? And why did you prioritize it the way you did? And that will help you when you get to a bump down the road. You can remember why it was high priority or low priority, and you don't forget about it. And then all that extra information that'll help you remember or to explain it, and then your links and your printouts of all your research and everything else so that it's all accessible to you.